All right, so hello YouTube, happy Friday. We are here having a pizza party and doing some code, like everyone should be on a Friday night.
Yay.
All right, so we actually came up with a better solution last night, but here is our single number array solution. So inputting a list of integers where every integer except for 1 shows up twice. Return a list of integers. June, can you tell me how this solution works?
So, um, so the count is the empty dictionary, right?
Mm-hmm.
And every number in array, if that number is in the count, which is the dictionary, then that count of the key will be increment by 1. Otherwise, it would add it as new key with the 0 value.
Mm-hmm.
And in every count that items, the value of that second, if the value is second index in the count items, if that is equal to 0, then return the value of 0 index. So
So we're returning the thing that has a value of 0.
Oh, okay. So value is array.
Value is the for key value in thing. So this is the value is part of the key value in the dictionary.
Okay.
How can we perhaps optimize this? Or maybe do it in place?
Wait, so count that items parentheses, what does that actually do?
It allows you to iterate through a dictionary.
Okay.
With their properties.
So the item parentheses is the library pre-made method.
This
right?
is a little object over here. That would have like the number 1, 0, and then we go and find 1, 4.
Oh, okay. Now I got it. Okay.
1.
All right. Thank you. So value 1 equals 0. Return value 0. So does are we just looking at the function single number, or?
Yes, we're just looking at this, and we're going to try and optimize it.
Optimize it. All right.
So this was our first pass solution. It's got 2 for loops. Can we make it better?
So, I mean, it's O of n, right? The time.
Yeah, that's pretty good, right?
It's pretty good.
It's O of n, but better than of O of n of time complexity, or could be no. I think time complexity should be O of n, and then maybe space complexity can be better. I'm not sure. If you say optimizing just for the code reading, then
so this is a pretty fairly would you say this one is fairly optimized, June?
Yeah, it's, I mean, so the purpose of this function is looking for what is it?
The single number in the array.
Oh, the single number in the array. Just give me a second. Let me close the door. Sorry, guys. 0 value count. Actually, maybe we can inside the, actually, no, wait a minute.
That's pretty good. So this method here, using a dictionary, is actually a hint for the GCA. This is a great way to store things when you have to do counting, or you have to see how many of something that there is, or when we're moving on later and we're talking about hash tables and we're doing cool stuff. It's a great way to store things in memory with a reference, right? So we could be looking for our key values and we can just sort things by the key and quickly see what we have in our dictionary. So that is
on the time complexity for that, though, would it make a difference if it's dict with invoking parentheses or if you just had the curly brackets there?
Same.
Oh, okay.
You can do dict, you can do you can do empty curly brackets.
So the syntax
basically the same thing.
Really...
No, but it's nice to look at.
Okay, I'm back.
Oh well.
Oh, your code is beautiful. But it can be optimized.
All right. What can we do, Doc?
So this is really not fair because I don't think you guys cover this.
That's what these are for.
Give me some
okay.
Give me some insights. I think it's already optimized for me at my level, I think.
Yeah.
The only thing I can think of is we can do some nested loops and not using dictionary.
The nested loops is better or worse?
Worse.
Yeah,
so
I
like
would call that an optimization.
So I'm sacrificing either space or time. But I can't think of, because here everything is open, space and time complexities. It looks good. But I can't think of any better than that, honestly.
All right, Doc. Teach us your ways.
Okay, so this involves using a bitwise operator.
Ooh, I don't know what that is. Awesome.
Okay, so I'm going to drop it into your thread, or I'm going to create a thread here in Slack and drop in the code.
All right. All right, Doc, you.
So what happens here is that we're using a bitwise not operator. If you look at the answer with the caret equal.
Okay.
And what that does is it cancels out the numbers that we've seen before, and it leaves you only with the one. So this is definitely something the bitwise operator or the bitwise not in this case is something you definitely would want to read more about.
So using that, is that like O of n time complexity?
It's O of n time complexity and O of 1 space. So the optimization is actually in space.
So we optimized our space complexity by only having one answer.
Yeah.
And this is a sorted array, so this definitely would work. But if it was unsorted, would it work?
Just sort it. There's a method. There's a Python method called sort.
Dot sort would work. Yep. That's really cool.
Yeah, definitely. I would definitely read about there's some really cool stuff that you can do with char methods and bitwise methods. I'm sorry, bitwise operators. There's also this thing called XOR, which is super useful.
Very cool. So this is if the answer doesn't previously exist, if the answer isn't this, return the answer. Awesome.
That's what it does.
Cool. That's really neat. Okay.
Down to only
So
one.
that was like, yeah, this is like, you know, something that you should like put down in your to-do list or your reading list. If you want to like go further with Python.
Mhm.
And
Alright.
it's, you know, Python is not, I mean, it's a language like a lot of other languages. So a lot of the operators exist across languages too. So it doesn't hurt to learn.
How to do things bitwise.
Yeah. I mean, bitwise is definitely something that you make use of when you start getting into computer architecture, right?
This is cool. This is super cool. All right, June, do you think that's as cool as I do?
Yeah, that's really cool. Definitely.
All right.
Definitely. I never expect that.
All
It's
right.
really cool to see. Yeah.
Yeah, you just want to fix your indentation on that.
Yeah, it's yelling at me. Where's? Oh, right. Boop. There we go. No.
I didn't realize that you could use
Well,
the
so the
in
yeah,
Python.
that should be all the way over to the left, right? You're not in a class, so
Yeah.
Can I have your attention, please?
Sorry.
no.
I
do not
need to
have my
start turning my notifications off.
So in line 21, why is that indented?
Oh. because of reasons, Doc. Because of reasons.
Because Ava's tired. It's
Oh
Friday.
gosh, tell me about it. It is beer o'clock on a Friday.
And you probably have that line 22 up above somewhere. If you didn't comment it out, the function definition, if you scroll up.
Oh, I did. I commented the function definition out.
Oh, okay.
All right. That is cool. All right. Let's check out moving zeros. This is a test. Moving zeros. There we go. All right. June. What have we got?
All right. Let's see.
So let's give you the README since you weren't here. Here's our README. Can you read the directions, please, while I eat some pizza?
I want to eat pizza too. But I'll read. Write a function that takes an array of integers and moves each non-zero integer to the left side of the array, then returns the altered array. The order of the non-zero integers does not matter in the mutate array. So 0, 3, 1, 0, 2.
All right. So.
So length of array. Let me.
Well, why don't you explain what we've got, what's going on, and how we think we can improve it?
Length array. 6 count 0. Y count is less than 1. If array count is equal to 0. Array dot append array count hop length. Okay, so there's a pen method and a pop method. And
So I'm.
Those are win-win. So this is Is this like a nested?
It is not nested. There's a single while loop.
So this is. Okay. What count is just that length? So there's a two method of pen and pop. How about we just use sorted?
All right.
So if we sort it,
So you want to do array.sort?
Yeah, and array.sort, then it's going to be 0, 0, and whatever numbers in the order. But we want the zeros on the right side.
Okay.
So, can we reverse? Yeah.
But I put a const there. Can you tell what language I've been in all morning?
Like array.sort.
Why are you typing it?
I mean like array.sort that reverse. Is that possible?
Google it.
Oh, I can Google it?
Yeah, of course you can Google it. Always Google your syntax.
As long as nobody broke your Google, I think you can.
Oh my gosh.
Sort dot reverse Python.
Oh, actually, we can do array.sort and inside the parentheses, reverse, type reverse equal true.
All right.
And return array, right?
Let's find out. Let's see, make sure that's saved. We're gonna test it. Test.
Before you run the test, can you just run the
Oh, that's right, there's one right there.
script?
Run. Moving zeros. All right.
I'm scared.
Looks like we have to return it into a variable.
Oh, -2. Oh. Okay. I didn't think of negative number. That's the problem right there. All right.
That would have been a really good solution, though.
It would have been. Remember, negative numbers have value too.
I know.
Yeah. Let me see.
That would have been very clever.
Oh, okay.
It would have been a lot better than what I thought up for it.
What did you think up, Joanne?
Well, it went right along with what they did last night in class, but it was the same thing that I would have done.
Well, go ahead. I thought that was pretty optimized last night.
Was it? Okay. I wasn't sure because it still has the for loop in there, so.
We had
for I in, huh?
Go ahead. For I in
ARR or array. And then if I double equals 0. And then ARR dot remove I. And then append or ARR append 0.
Well, this is much better than than my solution, which made some sacrifices in space complexity.
Yeah.
Doc, can we make it even better?
Yep, we can do it. We can do the we can do it in place without a loop. I mean, not without a loop. That's the lie. But we can arrange the. This is very reminiscent of when you did like doubly linked lists, and you had the previous and the current, and you swapped them. So it uses a swap instead of the pop and append stuff instead of the iteration.
Mhm.
It just says so this what this does is it does not optimize the time, because the time is going to remain O of n.
Mhm.
But it does optimize the space because it uses a swap.
Actually, so mine was pretty close to Doc's, except I had the append thing.
Yeah, so if you do the swap, you actually save you're at O of 1 space instead of O of n.
But that's a lot more code.
So what is it we're optimizing?
Time and space complexity, not the amount of code we write.
That's what I was kind of thinking.
I know.
All right, so June, what do we do here?
Wait, are we still doing the same question?
Yep, we have optimized it.
Oh, so that's the optimized?
Mm-hmm.
Yeah, can you read the code and see what it's doing?
Yes. So, do you want me to go over?
Yes.
Okay. So left is 0, right is the last index of the item.
The length of the array -1.
Yes. And
so we have the same setup that we had with mine, except that we did something really cool in the middle.
Yeah, we've got 2 pointers here.
And if array left is equal to 0 and array right is not equal to 0, then we're going to swap it.
Yeah, doesn't this look like what you guys did with like current and previous in the doubly linked list? Doesn't that look familiar?
Yeah.
This is actually pretty smart. So swap it, yeah. And until swap it, and then left and right is going to decrement and left is going to increment. And if right, array of right is equal to 0, then we're gonna go to else statement, and if array left is not equal to 0, then left is going to increment.
Yeah, because you're looking for zeros, right? So if you find a non-zero number, you're just going to move your pointer forward until you find a 0.
Yes. If array right is equal to 0, then decrement the right.
Yeah, because your 0 is already out on the right.
Actually, that's pretty good, I think.
That's really cool. So now we've got 2 really optimized solutions. All right.
I don't know.
Wait, hold
No? What do we vote?
Wait. Can I ask about that line?
There's a
That
kitty.
he... Oh yeah, line 26. What does that mean? You're just swapping them? That's it?
Yeah, it's just, if you remember, are you in CS?
Yes.
Okay, so remember when you did the doubly linked lists and you had the current and previous pointers? or the next pointers, and you would swap them.
All right, that's just the syntax for swapping. All right.
Yeah, so will you indulge me here for a second, Ava, and let me do a little drawing?
Yes, you can draw. I will watch and eat pizza.
Okay.
I've got a question for you, Doc.
Okay, so hold the phone just a second, Joanne.
Okay.
Okay, so we have an array, and our goal is to find zeros in here and put them out on the right. So we create a left pointer and we create a right pointer. And if this first number here is not 0, then we just move the pointer. We increment the pointer to the next value, right? Conversely, if all the way out on the right we have a 0 that's less egg-like, then we want that 0 out there. So we would simply move the pointer to the next position. Okay, now the swap. So we have our array, and if array left equals 0 and array right does not equal 0, then array left and array right equals, this pointer moves here and this pointer moves here. Now, what does that look like? That looks like your doubly linked list, right? So the result of this is you're going to end up with this item here and this item here. And then we're going to decrement the right pointer one spot to whatever this value is here. I don't remember what the example was. And then we're going to increment the left pointer one position to whatever this value is here. So
All right,
now
so yeah, sorry to interrupt.
and so as long as the left pointer is less than the right pointer, when they meet in the middle, or if they happen to cross, then the while loop will exit. Did that make it better or more confusing? I probably drew too much on this one array here. Sorry about that.
No, I think it always helps. I'm a visual learner. So basically, yeah, it's like a double linked list, and you're adjusting the pointers from both ends until they cross and looking for zeros in the meanwhile.
Yeah, if you find a 0, you're going to shove it out to the right. If you have a 0 already out to the right, you leave it alone and move the pointer. Yeah, so the difference between this solution and this solution up here is, up here you have one pointer. Down here you have two pointers.
Oh, the one we commented out? You have, that's the first solution?
Yeah, this is one pointer. Because you've got this count thing.
I had the beginnings. If I'd counted from my length.
Yep. Yeah, you were very close. Well, and again, it's like so this is making an inferential leap between knowing how, having experience with two-sum, which is a two-pointer solution. You know, it's like building experience and knowledge, right? So now I know, sometimes I know when I look at a problem, oh, okay, I can use 2 pointers here. Does that make sense?
Mm-hmm.
I mean, when can you not use 2 pointers? I don't know. It's always faster to use 2 pointers, right?
So if you're using recursion, you can't use 2 pointers. If you're doing a Fibonacci sequence, for example, 2 pointers doesn't help you there. If you're doing a graph problem, 2 pointers is definitely not going to help you there. There's like any number. I mean, so one of the prerequisites for using a 2-pointer solution is you have to be working with Python lists, what you JavaScript people like to call arrays, but they're actually lists in Python. So if you're doing that, then you might consider a 2-pointer solution. But if you're working with dictionaries or sets or, you know, some other algorithm that doesn't, you know, that doesn't involve like iterating over a list, then 2 pointers is not going to help you. Explaino?
Yeah, you had said if you're using, for example, recursion or
A graph problem?
yeah, graph problem. Was there one other example? The data structures you said, Rex, dictionaries and sets.
Yeah, if you're using a dictionary, which is a, you know, any kind of hash map or key value store, well, there might be some instances, and even with a key value store, where you could use 2 pointers, but it would increase your. I mean, usually when you use a key value store, you're trying to do just a simple lookup, which is O of 1 already. So there's no value to using 2 pointers in that case, because you're just doing a lookup. You're not iterating over the dictionary. You're just extracting the value based on the key or something like that.
All right. Yeah. So what was the last? You said recursion, graph. Was there another one? Or I could just watch the video later if you don't remember the third type. But
there's a bunch. I mean, I can't name them all for you.
Oh,
I mean,
no.
there's a whole class of problems where. So I mean,
all right.
dynamic programming is an interesting. You guys should read about dynamic programming if you don't cover it in CS, because it's super important in terms of solving code challenges like the ones that you'll face in interviews for optimization. So what dynamic programming is putting an algorithm inside of a data structure. For example, a cache is a data structure. So if you wrap your algorithm in a cache, what happens, Ava?
I don't know yet. I'm learning about it.
You save space. So if you've seen something already and you've saved it to cache, then you can just pull it from cache. You don't have to, time complexity. You don't have to go back to the array or whatever and iterate because it's in cache. There are 2 types of dynamic programming. One is called memoization, and that can be cache is part of memoization. There are other types of memoization, and that's basically what they call top-down dynamic programming. And then there's bottom-up dynamic programming, and that's called tabulation. But definitely this is an area that you guys will want to understand before you start. If you're doing, you know, leak code, and if you're interviewing at companies that require that kind of stuff, when it comes to optimization, you're going to want to understand dynamic programming.
So
there's always more to learn.
So then just having shorter code is not optimizing.
No, optimizing is reducing the amount of space you use or the amount of time that you use. And sometimes, somebody mentioned this earlier, which was a great insight. Sometimes you want to sacrifice one for the other. Depending on the kind of data that you're handling or transforming or moving or whatever you're doing with it, the RAM may be plentiful, and what you really want to do is save space so that you're not hitting the disk drive as often. So you might want to optimize for space and increase your time complexity. So there's all kinds of considerations here for, what is the best approach using code to solve a problem.
Did you mean decrease the time complexity?
No, I mean increase the time complexity and decrease the space complexity. So the gating factor
Oh, I see.
in software is I/O. That's the slowest part of the system, right? Reading and writing to a disk. Slowest thing you can do. RAM is cheap. So, if your solution in certain situations, if your solution uses more RAM and accesses the disk less frequently, so optimize for space, not optimize for time, then that would be the thing to do. So I'm just saying this to point out that, like, it's not always, clear cut. The only time you totally want to optimize for whatever you can optimize for is when you're interviewing and using code challenges.
Well, like in DS, I mean, when we run our models, one thing that I've ran into during Unit 4 is getting the models to fit with the available RAM that I have. Like with Colab, I kept crashing the RAM.
Crashing what RAM? Where are you running your model?
On Colab, Google Colab.
Oh, okay. I don't know how much RAM they have.
My husband ran into that exact same problem, Joanne. June, can you... This is a somewhat optimized solution. Can you read and tell me what... This is actually one of mine. So can you read and tell me what this is?
Okay, so the length, saving length of the array. The output will be have length of the array, bunch of zeros on it.
Do you remember what we called that?
And the output 0 is 1. So the first, yeah. Okay. And the for loop, it's going to start at 1, index number 1, till the last index of the array, I think.
Mm-hmm.
Yeah, length. And the output is equal to...
so the output of I...
I is equal to the output I minus 1 and times the array minus I minus 1.
So output is, they're talking, is that, it's like the output from running whatever index through that function, product of all other numbers?
Mm-hmm.
All right, thanks.
And the accumulated is equal 1. And another...
Doc didn't like this variable, so I'm going to change the name.
Another...
So every code, all the code we're looking at is Ava's from the CS project, like project 1, from all the different modules.
This is from the algorithms project. This is just one of my answers.
Was that unit 1 CS sprint 1?
This is not a sprint. This is
No, I know it's not, but it. I'm sorry.
This was from the
homework
CS module project algorithms.
Oh, I see. But do you remember that was unit 1 or that was before
that was unit 1?
Oh, okay, thank you. Sorry.
This is I did this on my own time. I took the same CS that everyone else is taking.
Thank you.
And then...
So what is the accumulated for?
The accumulated This is the one that Doc hates my naming convention, so I'm gonna rename it. The product.
Oh, okay.
Because I thought accumulated made sense because it's an accumulated product, but it is the product.
So for the loop, it's going to start from the I is going to start the length minus 2 till the index of 0, and it's going to decrement by 1, and the products is going to increase by multiplying by the array I plus 1, and the output I is equal to output I times product.
Sorry, 17 length minus 2 is the start. Is it supposed to be length minus 1 is the end, or
it's reversing
it's stepping,
it?
Right?
Oh, well, that's what that last parameter means, right? Argument. But what's the middle argument?
I honestly don't remember. I think I was drunk
Oh no.
and Googling.
Oh, if you hover over it, it gives it to you.
When you have a range,
The
you
middle one
No.
stop,
is the left.
and then the step. Right?
It's length minus 2 because you want the second to last. You're gonna start at the second to last element of the array, or is this slicing?
This is a for loop, so we're starting at the second to last minus
Okay.
1, and then reverse. I think it's reversing it.
Yeah, it's not
Okay.
it's not slicing. It's the range parameters.
Okay, yeah, I'm not totally familiar with range the function, but that's cool. But it's start, stop, increment, like as if it was colons.
Yeah,
That's slicing.
Yeah,
Okay, slicing is colons. Okay, thank you.
yeah, that's right.
That's similar concept. All right.
Yes. Yeah, when you slice, you don't need the you don't do that inside of the range method.
Yep.
Okay, thanks.
You're welcome.
The range functions the same way as the array dot length when you're doing a for loop in JavaScript, and I just realized that you are not a JavaScript person.
Yeah, no, it's cool. I mean, I've done it, but not at all much. It's a couple years ago. It just seems a little redundant to me, like when you define a range with a for loop. But I think it's probably not redundant. Otherwise, people wouldn't do it. I guess, yeah, you don't want to iterate through the whole array, so you're specifying a piece of it, essentially, right? That you're iterating through.
Well, you're also saying use this as an index instead of using this as a value.
Right.
Yeah, I mean, I'm familiar with counters and indices.
So we're using an index here instead of using a number.
Oh, okay. So a number would kind of be.
So if I had said for num in array, then I could say then I wouldn't be able to do this extra stuff here.
Oh, fancy.
So we can do this because we're working with the index.
Okay, thank you.
Ava is a star.
All right, Duck, is this optimized?
It can be a little bit. I mean, as far as like time and space complexity, I would say you're good. I would make it a bit more Pythonic.
All right, how can we either make it better and less worse?
In the Slack.
In the Slack. All right. Oh man, yeah, Docs is tidy.
Now, is there a way to get away with not doing so many for loops?
There is not.
Okay.
Well, I shouldn't say that. There might be, but at least for now, the approach that I came up with is not exactly the same as the approach that Ava's using, because I'm actually using, I thought you used division.
In my gross solution, but not in this solution.
Yeah, because didn't it say you had to do it without using division?
No. Where did you read that?
Oh, I thought that's what it said in the README.
I'm pretty sure it did not say that.
Maybe I was looking at a different one.
Could be. There's quite a few problems here.
There's a lot of problems here.
Yeah, it says,
Oh.
can you do this in O of n time with O and n space without using division?
Well,
that was the
fucking
challenge.
annoying.
That was the challenge of like your extra super fancy challenge.
Oh, okay. So doing it without division. All right, then let's see.
What's the line? Why do we need a line 30 loop?
Because we have multiplied everything by every number, including where we're currently at. So we need this one to divide and remove that one number that we shouldn't have used.
Wait, what was the question?
Okay, so we have, everyone's gonna regret this because Ava doesn't do math. So we have an array of 2 and 2 and 2 and 2. And okay, we're only gonna go as high as 4 because this is the extent of my math. So 2 times 2 times 2 times 2, I think is 16.
Yeah, ding, 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 ding.
All right, so we have 16, but it says of all other numbers. So this is 1 times 2 too many. So we're going back and dividing it by 2 because this is how math works. And we get 8, and this is the correct solution.
It was just kind of a hack, you mean?
Yes, Doc is doing hacks.
No worries.
Wait, so what's the input?
It's not a hack. Who said that?
Me, sorry, I didn't. And then she confirmed it.
Yeah,
she was
Doc
teasing.
used-
I need to
Doc
take
used
Adderall.
division. Hacks.
Yeah,
What
she
is
was
the-
teasing.
What is the input of array?
The array is going to be all these numbers.
So we are multiplying.
So you're going to
everything.
multiply 2 by all of these other numbers, but you're not going to multiply it by that one too. So if we're going to do, again, y'all are going to regret this. Okay, so
That's the new Ava catchphrase.
Everybody knows Ava's bad at math, y'all. 1 times 2 times 3 times 4 is 1 times 2, 2 times 3, 6. 6 times 4 is 24?
Yeah.
All right, cool. Okay, I think this is also 24. Yeah, it should be 24 because it's the same thing for all these stuffs, right? Cool, great. So this should still be 24 because of reasons.
Wait, why is it?
24 this should never have been multiplied by 2, so we have 12. 3, this should never have been multiplied by 3, so it's 8, 8, 8, 8. Cool. And the last one should never have been multiplied by itself, so it's 6. So that's what the array should have been.
You mean the input array?
The output array.
Output array. So this is some kind of like manual brute force fixing of what we want the output to look like?
So we're given an array 1, 2, 3, 4. We are going to multiply the 1 by 2, 3, and 4.
Okay.
We're not going to actually multiply the 1. That's the thing. We're not multiplying the 1. We're multiplying 2, 3, and 4. And we're getting this. And then we have 2. And we're going to multiply 1 times 3 times 4. Everything but the 2.
Yeah. Okay, that's a complicated little thing they want us to do. Okay.
Yes. This is it.
Thank
All right.
I'm curious. So, Doc, are you also friendly about sharing your GitHub solutions with the rest of the gang, or no problem?
I don't understand. I don't understand the question.
Oh, I mean, because Ava shared her repos, for us to learn from. So I wasn't sure.
Oh, yeah.
Or-
I usually just like I usually share my code like right in the Slack during these. What
Yeah.
you do, G's? Yeah. Give me 1 second here.
I mean, but wait, you're in DS? I forget. You're in web, right?
Yeah.
Oh, okay.
I'm nowhere. I'm in cyberspace.
Yeah, me too, actually. Hi, nice to meet you. Okay. No, I know. And I wasn't sure if Joanne, because like I'm just just hanging out with my teeth and nails,
Yeah, well, you come to the right place.
I really feel home here, ladies and Joan.
Good.
Sorry, G.
That's good.
No, it is, because I've come through a lot of this hard last couple months, real traumatic, and I'm like, I don't even know if I'm just gonna hiatus or what. But then my mom's like, don't, just try to fight it through, and I got a lot of support from the community, so I'll see if I can push through. And this
All right, Joanne.
Ray of Sunshine.
I got it. I got the no division solution for you.
All right, post it. All right.
Oh, you just woke June up. He was sleeping.
Was he really?
And I looked like it.
That's
right.
adorable. That's adorable.
Y'all put June to sleep.
No, I'm not in sleep. I still want to eat pizza, so don't worry.
All right, so what do? I push Shift and Tab, and then everything is broken forever.
See, what did you do?
Oh my God.
Guys.
Control
This is something.
Are you on a Windows machine or a Mac?
I'm on a Windows. When
Okay,
I copy from Slack, it adds like a single extra space,
so
and everything is evil.
Yeah. Oh,
So
that sucks.
it's fine. It only takes like a couple of seconds. So, hey, so it is pretty close to my solution.
Yeah, I told you.
I feel smart.
You should. Okay, I told you last night that this was a great solution. Okay, so throw in some vertical lines there for me.
The only thing you changed was you moved 2 things. All right, vertical lines. Where did my vertical lines go? Here.
Yeah.
More.
One after 37. Well,
No, there.
Oh.
After 37.
Derpy derp derp.
Yep. That's it.
Alrighty.
Wait, go down. One after 47. There you go. Beautiful.
All right. So the only thing you changed from mine is that you took away length and just like used it there and typed it out each time. And your product so far is in your for loop and mine is outside of the for loop.
Yeah, there's not a width difference between the two. They both do the same thing.
And you did -1, -1, -1, and mine is -2, -1, -1, because I have stupid things inside these spots. Cool. Well, I feel cool.
Ava, you are so cool. You are a woman of many talents, and I admire you for all of them.
Me too, and I only known her like 3 sessions.
You have no idea. This woman.
I got envy. I got Ava envy.
Yeah.
Y'all gonna
me
make
too.
me match
me
my
too.
shirt.
We want to be like Ava.
All right, we're gonna go eating cookies.
Yeah, baby.
All right, so this is a somewhat optimized solution using one of my favorite tools. The cache.
Can you say it with feeling?
The cache.
Yeah, I think that works because it's kind of sneaky on the DL.
This is very sneaky. And we're using a lot of my favorite thing, guys.
I thought cache was your favorite thing.
I know, but our best friend. Recursion. Recursion. All right. So how did we do here?
Let's see. If cash, should I take a stab? I don't know.
Go ahead,
Absolutely.
take a stab, Tita.
Yeah.
I'm trying to stab these cookies for Cookie Monster. Okay, so it's a function. It takes, I guess, n is a number, and cache is an empty set, I guess. Okay, if the cache, okay, now that's comparator is an empty set. We're gonna define, I don't know if you'd say initialize, I guess. Initialize it at the index, I guess, 0 for I. Is that the starting? I'm not sure about that syntax. Oh, is that an regular expression?
This is a list comprehension.
Oh, okay.
Except it's not a list, it's a dictionary comprehension.
Yes, it is.
Oh, I said set. Wait, sets. Which brackets does sets have? Or sets are type of a dictionary? I forget.
Sets have the same type of brackets.
Oh, it has the curly braces. Okay, but it's, how do we differentiate? It's just
sets have unique.
And list comprehension is that gobbledygook in the middle.
So it's the brackets that are different for sets, and also in order to have a set, you have to have unique values.
Okay, I thought you said that the brackets were the curly braces for sets and list comprehension.
I did say that. I just repeated it. I said the use the same brackets as you do here for cache. You've got the curly braces, right?
Okay. But we
so
can.
Curly braces are used both for dictionaries and for sets. That's what I'm trying to say.
Okay, but in this case, Ava said this is a list comprehension, or the highlighted in
That's a dictionary
comprehension.
Yeah.
So inside, so cache is a set, correct?
No.
Cache is a dictionary.
Cache is a dictionary. Thank you. Cache is a dictionary, and for key value. Oh, I see. So the key is the index. The value is 0, or is that no? Yeah, 0 for I in range, and +1. So that's so condensed, man. Let's see. It's 0. Oh, because you're setting them all equals to 0. You're initializing, correct?
Mm-hmm.
Okay, empty cache bucket. Oh, did you just play? Oh, I love comments. Yay, makes me happy. Okay, dictionary comprehension thing. Oh, you can use that kind of interchangeably. You can say dictionary comprehension, or because in this case it is.
Because in this case it is a dictionary. It's not a list. We're making a dictionary.
The comprehension keyword it's a data structure, right? Or no?
The comprehension is the verb.
Okay. So I don't comprehend a comprehension. Okay,
so the purpose of a comprehension, whether it's a list comprehension or a dictionary comprehension, is to create that data structure. So a list comprehension creates a list.
List comprehension.
A dictionary comprehension creates a dictionary.
Thank you. Thank you so much.
You're welcome.
All right, so let's go on. I'll try to jot that down later. Okay, so now you're doing another if. Can I call that a clause or statement? No.
If statement.
If statement, you can't call it a clause. Okay.
It's a condition.
So if n.
Condition.
Oh, okay, right. It is. Yes. So if n is less than 0, we're going to return 0. And then it says if 0 cookies, only one way to eat it. Else if n is equal to 0, you're going to return 1. Check the cache to see if the answer is stored in there. If cache and cache at n are greater than 0, then you're going to return cache at n. I mean, the and operator is just like straightforward. It's like you have to do both conditions, correct? You check both conditions there?
So if the cache exists and
okay, if cache exists.
And the cache at the current number is greater than 0.
Okay, that's helpful. Then you're going to return the cache at the current number. Else, you're going to store the answers in the cache. Cache at the current number is equal to that function, our function eating cookies from the end of the list.
So eating cookies in -1 cache plus eating cookies in -2 cache, plus eating cookies, and -3 cache.
Those arguments are, oh, you're just passing in both because it needs both arguments.
Mhm.
Okay, and then you're going to return cache at the current index. All right, so that's it. Then you have the main, oh, you have a driver function. When do you need that? Because when it's not, when you have it in the file, it's like better or something. I forget because
This
Java
part,
does that.
this
Yeah.
part is written by whoever made this very lovely test section, so I have no idea.
Well,
Doc!
it looks familiar. Yeah. It's like if you're calling the function from another file, I think you need that or something like that, right?
No, it's a way to run the file and put in like dummy inputs into it.
Yeah,
So-
if you want it to be executable, you can write this as a script and not make it executable, right?
I see. Okay, so you always need this block or condition.
Well, you need it if you're going to run this file.
Just
And then,
run it on its own.
yeah,
All right, thank you. What am I thinking of when you have something that looks similar? No, that's a dunder function, right?
if you have a dunder function, you're probably overriding a method in a class.
So because that dunder function, there's no space between the two spaces, so this is not a dunder function, right? This is not even a function. It's just a condition. Okay, I'm just mixing it up with something else where we had multiple files. And
Yeah.
if you're calling a function in another function from another file, then you need something that looks like that. But that's just my confusion here. Thank you.
All right. So, is this optimized?
Great question. Well, first we want to figure out what's the time and space complexity as is, and then see if we can do better or something, I guess.
Yeah.
Oh, sorry.
So we've got a lot of recursion going on. Recursion's pretty expensive. We could do it in a while loop, or probably not. Who knows?
You could absolutely, anytime you see recursion, you can use a while loop, but if you're going to iterate, then you're probably going to have the same time complexity. So what makes this optimized is the fact that this, ladies and gentlemen, is an example of dynamic programming, where you take your algorithm and put it in a cache, which is a data structure. So this is also called memoization. So yes, it's optimized because of the use of cache. But Ava, you already knew that.
Everybody Google.
Yes, everybody Google.
This solution was brought to you by heavy use of Google. And I do mean heavy use of Google. Because Ava doesn't do math.
Apparently she does. Ava's doing math all over this video tonight. She's spreading the math everywhere.
So we have something, kind of. It exists. Or we have a really good solution that it took me like a lot of collaboration in Google to come up with.
Okay, so what are the required components of recursion?
Anybody? Bueller? Bueller? June?
Base case, and which is like when it'll stop recursing. And
Yep.
June, I hand the conch to you.
June, you've got the conch, man.
Lord of the Flies. I don't know if you read that. Beautiful, beautiful story. And tragic too.
Okay, so here's the base case. What are the other elements of recursion, June?
What do you mean? What element?
So there are three elements that every recursion has to contain.
Mhm.
One is the base case, which provides your, just like Theta said, this exits the recursion.
Mhm.
The second is the function has to call itself.
Uh-huh.
That's pretty straightforward. And then finally, the recursion has to always be moving toward the base case. And there's another thing that you probably want to understand, because this is an assignment statement right here. Everything on this side of the equal sign gets evaluated before it ever gets assigned here.
So it's going to return rather whether 1 or 0, right? At the end.
No, remember,
I mean like, so if the n is 5, then the first eating cookie recursion is going to give n equals 4, and the second one is n equals 3, and the third one is n equals 1, and the last recursion function, which is the n minus 3, is going to return I think 0 and 1, because recursion is keep repeating the function of again and again and again.
yeah,
like a tree shape, right?
Yeah, June, I would really recommend that you go and do some more reading about recursion and how this focus on like how this gets executed.
I have maybe it'll help if I can interject.
Yep.
Okay, so my C++ data structures instructor, we all sat in rows in a physical classroom. And so I think his example was, whatever the task was, say, to figure out how many cookies are in the jar, in a multi-layer jar or something. So he said, okay, first row, you're going to count how many cookies are in the first layer of that jar. I don't know about multi-layer jars, the kind with the screws, maybe, I don't know. And then the second row is going to count just how many cookies are in the second row of that jar, second section, and the third row, the third, right? And then you're going to have the third row pass up their answer, their count to the second row. Like I'm talking about row in the classroom now. And then the second row is going to pass up both their answer for how many cookies in the second row of the jar, and also the answer they got from the back row of the classroom for how many cookies are in the third row of the jar. And then both of those.
That's a great example.
Yeah, that was so clear and great, and I think he even passed out papers. It was great, like very clear. Does that make sense, June? Like if you can picture a classroom with, rows and students, and then each row is assigned like a specific task that's part of the same, problem set, and then you each pass up your answer to the row in front, and then it's cumulative or whatever. That's kind of, yeah.
Yeah, that's definitely helpful, yeah.
Yeah, he's a great teacher.
Uh-huh. I mean, recursion, yeah, I definitely understand. It's just not too familiar yet. So
yeah, that's why I'm suggesting you do a bit more reading on this. And also I would suggest that when it comes to recursion, that you're familiar with how the call stack works.
Mm-hmm.
Is that something just CS, or is that something Java?
The call stack, like the like which one get executed first, right?
Yeah.
Okay.
So as you're doing recursion, you're building up the call. And
so that's why
when you've exited, when you hit the base case, then you start evaluating. So you've got your stack for however many recursions you've done, and then you evaluate this one. It's exactly what the just. Can you do that description again, because it is so perfect? I'm just going to be quiet. Can you talk them through that again?
Sure. And I'm sorry, I might have muddled it up or something a little bit. But say you're physically in a classroom with 3 rows of students, and then the teacher asks us as a class to like count how many how many cookies are in a multi-layer cookie jar. So as a team, as a classroom, we say, okay, the first row of students is going to count the number of cookies in the top section of that cookie jar. Second row, that it's going to count the cookies in the second row of that jar. The third row of the classroom is going to count how many cookies are in the third row of the cookie jar. And then we're starting from the back end of the room. That third row is going to, give their answer, like say 5 cookies, up to the second row of students. Say, hey, we had 5 cookies in the third row of the cookie jar. The second row will be like, all right, cool. We have 4, so it has their own answer plus the back row. And then the second row gives both answers, the 5 and the 4, from their own, and from the third row, that their counts up to the first row, and say they have 2 cookies, right, in the top row. The top section of the cookie jar. So all together, they're responsible for adding all of the 3 different answers, and then you put it together, and then you return the final answer to the teacher. How many cookies were in the cookie jar? If that's clear. You could probably look at Stack Exchange with visual, and they do short videos. And then what's the other? 3 blue, 1 brown, or 3 brown, 1 blue?
This is the first row of students. This is the second, what the second row of students is assigned, and this is what the third row of students is assigned. So you've got this one that goes on the stack, then this one goes on the stack, and then this one goes on the call stack, and then you evaluate this one first, then you evaluate this one next, and then you evaluate this one last. It just functions exactly like a stack. And so now that you've got each one of these evaluated, you add them, right? This plus this plus this. And now that all of that is done, you assign that final value to cache at n.
And if you want a little bit more on stack, like a good visual mnemonic is also literally, if you've been to a buffet and there's like a stack of plates. So, somebody refilling, like the stack of plates, they put a whole bunch in, and the first one that pops out at the top of the buffet table was the last one that went in. Right?
Yeah, I think that's the easy part to understand. What I'm trying to illustrate with this call stack is how this stuff actually gets evaluated.
Okay, is it not
so like if the order of execution, if you will? Ava, stuff keeps popping up on your screen, dude.
I think Joanne, I'm sorry, Doc, isn't that related though? First in, last out. So the first whatever calculation that was done.
Yeah, but that's the part I didn't want to lose. Like, there's all kinds of stacks, right?
So
the stack is specific to executing code, right? So
processes that the computer's running, right? Each task.
Yeah. So you load up the stack with each one of these before you evaluate any of them.
Okay. As a separate thread.
It's almost like if you're talking mathematics, you're putting them into brackets or parentheses.
Right. Cool.
Before you add them together.
And the idea is that because it's on a stack, you're going to evaluate the last one in will be the first one out, and so on. And then once you've got each one of those evaluated to its value, then you're going to add them together, and then finally assign it to this cache. So it's what I'm trying to highlight is the order of operations of this line of code right here, because it's a little, if you haven't read about the call stack and stuff like that yet, then understanding how this gets evaluated, how it gets executed, might not be as clear. So I don't know if I made it more muddy. That wasn't my intent, but.
Boy, Doc, I got a whole bunch of sticky notes all over the place tonight because of you.
Like actual sticky notes, the virtual ones.
Actual sticky notes.
Cool. Nice.
So
nice.
yeah,
No,
so
I'm very like real world oriented. Like I have so much stuff.
So is that good for you, June?
Yes. So, okay, my question is, I think you guys already explained, but I just want to make confirmation now. So, so this section right here is going to get into the call stack for sure. And this is going to be first executed from the call stack or this one?
the one on the end.
This one?
So last in.
Uh-huh.
So you're just loading when you go through. So you hit this eating cookies, right? That gets thrown on the stack, and then you go down and it says, "Oh, eating cookies again." That gets thrown on the stack, and then the third one is eating cookies again, and you throw that on the stack. Now you've gotten to the end of the line, so you start evaluating the last one that you put in first, because that's what it means to be a stack.
Okay. So.
But Google call stack and recursion. Because that'll give you more examples to look at. And so the final answer, once these have all been evaluated, and you hit the base case here, you're going to return whatever was assigned.
Okay.
You're
I was just curious.
You're going to return whatever was assigned here, which is.
Hey Doc, I got the book.
Yay! Oh, sorry. Thank you.
You're welcome.
Another one of Ava's talents. Your screen keeps like blinking and flashing stuff.
It's because I have to keep because I'm like going around all the different things I had running to get the to get the one thing and extract it to the other thing and convert it to another thing and finally download the final thing. So my screen was flashy because I was going between like 8 or 9 windows.
All the things. Got it.
Yeah. You want PDF? I find.
Thank you very much. And you're just going to toss that in the library, right?
Mm-hmm. This one will go in the library.
Excellent, excellent.
All right, so that is the end of the. There are other problems. There are stretch goals. I haven't done any of them, so we're not going to look at them.
Oh, so that was the end of the assignment 1 for module 1, and
this is the end.
This is the end.
Algorithms of week 3 in unit 1.
There's some really good problems in here that are important. Definitely, all of you guys need to do sliding window, because that is a pattern that you will see a lot in code challenges, the sliding window. Well, all of these really are really common. All of them are really common problems for code challenges.
Doc, did I do this one?
What is that one? Sliding window.
Did I do that? Or was I just starting on that?
I think you were. You don't have enough code to have it finished, so.
Let's see. It looks like I was starting on it.
Yeah.
No.
Passed.
No, I passed.
I guess you're done.
No. No.
Yeah, that was the max. Let's try max large. Let's start with a large input. No way. Yeah. It was timing out. That's why.
Okay, go back to the other one.
This one?
Yeah.
I need to stop this. So it's running. Hang
no,
on.
not the test. I want to see the code for a sliding window. Okay, so I k -1. Oh, that's weird.
There's a weird solution. I don't know. I do code challenges and have beer.
Hold on.
Range length of numbers.
Okay, and what is the what's the time complexity on this?
Probably lots. Because I'm using append max. No.
Max is an iterator, that's right.
Yeah, this is doubly. Yeah, this is essentially a nested for loop. This is.
Yeah.
I was excited about this.
And then some.
Yeah.
And what's the space complexity?
Lots.
Okay. So I'm just going to give you a hint on this one, and then you can like look it up.
Do I need to get my sticky notepad out?
Yes. Well,
Okay.
maybe not. Maybe not. So what you want to do here is use a Q and
Did anybody ever figure out that import problem?
No.
and specifically a deck. You want to import the deck from the collections.
Okay, now I need to figure out what a deck is.
Yep.
No, not it's not spelled like that. It's DEQUE.
It's like DQ.
Oh, DQ.
Yeah.
I
Oh,
got confused at that too when the teacher Tom was just talking to that, and I was thinking DECK, like a deck of cards.
All right. All right.
And that if you do that solution, Ava, it'll handle the biggin.
The biggin. All right. Well, we have. I'm not even gonna look because I'm too curious about what work I did and what work I didn't do.
Oh, come on, let's look.
Because
come on.
Oh, there you go. Ha! I definitely. That's as far as I got.
It's a start.
It is a start. I don't think I started on knapsack. Nope, did not start knapsack. And
making change.
I don't think I did making change. Nope.
Also, super common problem. All of these are really common problems in code interviews, which is I'm sure why they chose them.
Yep.
I ended up doing making change in that other course that Ava took too.